on. Yeah, right. We have a session. There we go. Hello. Hello, everyone. What's this? Reload required. Alright, sure. Alright. We have a reload. Nice, we got that duration. Still looking for viewers. Looking for people who chimed in. This, is it past? Yep, it is. We got the right stream information. Yeah, yes. Anyone? No one chimed in so far. Maybe there's a delay. Yep. You can share the stream. I didn't know there was an ad stream marker. Hey, I need someone to chime in. Need someone to say hello. Hello. Need someone to say hello. Apparently we got 8 viewers on. Alright, someone gotta send a chat. Let me just send something. Hello. Hey Sam, okay, there we go. Okay, hey Sam. Hey Mirza G. It's Mirza G, yeah. Hello. Okay, you know the drill. Mic check, audio check. Mic check, audio check, video check. How we doing? And we need to do a video check as well, too. That's important. Hey, Gold Energy. Hello. All right. Thanks for tuning in. Thanks for tuning in on this Thursday. Yep. Thanks for tuning in. It's now October. All right. All good. Now we got Linda. Hello, Linda. Hello. How are you? We got Linda. We got Sam. We got Gold Energy. Yep. Hello. We got a minute. Yep. We got a lot to do today. A lot to do. It's a fun one. It's one that you'll probably encounter. Certainly a topic that you will see on a daily basis, and perhaps even something that you may need to do eventually in your career. Yeah, today is all about passwords. Yeah, today is all about passwords. I'll begin at the bottom of the hour. I'll begin. Hey, Mystery Flower, how are you? Howdy, Mystery Flower. All right, we got some viewers on. We have the viewers on. I'm actually going to need your help, each and every one of you here today. Hello, everyone. It's 4:30. Welcome to Introduction to Security. I'm Ming Zhao, Associate Teaching Professor at Tufts University. And we are now in October. October is National Cybersecurity Awareness Month, and it is also Breast Cancer Awareness Month as well. Okay? Hey, Rich Man, Poor Man fan. Yeah, it's been a while. So, before I start today, there's something I usually don't do, and for the first time ever, actually I take the honors for this one, I would love to wish a very happy 21st birthday to former student Leo Kozluzny. Kozluzny. So, happy birthday, Leo. Happy 21st. Best wishes. Stay happy, stay healthy. Also, might as well give a shout out to friends Sam H and Richard Diamond. Yeah, hopefully you guys are going to be taking Leo out for a drink tonight to celebrate the 21st birthday. Yes. I mean, I would love to actually hang out with you guys, but I don't drink anymore. I don't drink anymore. Hey, G. DeRossi. Hey, DD Band. Yes. So, want to give a shout out. Yeah, they took security last, what is it? Yeah, it was last semester, last spring, which was awesome. I knew what the three of you always sat in the front. Well, fun times. Yeah, so, happy birthday again, Leo. Best wishes always. My cheers to you. Okay. So today we are going to do password cracking. Yeah. Password cracking. We're going to start by, actually how to store passwords incorrectly. Then we're going to do a little bit better. Then we're going to do an optimal solution Then we're actually going to have fun and try to crack passwords. And this is today's one of those days I'm actually going to use viewers. So let me do an example here. Let me do this one out. So here I have Visual Studio Code open, and I'm going to just write this out. I'm going to write this out, and I say I'm going to have a database table called users. Okay? And I'm going to have two fields, login and password. So we're going to have a database table of users. Now, if you're not familiar with the whole idea of a database, don't worry about it. Just imagine that this is a spreadsheet, or a spreadsheet of user accounts. Here we go. So I'm going to have a login of DDBand. And your password, I'm going to say, is I'm going to give you the long password, okay? Golden Energy. No, it's actually Goldine. There you go. And your password is... Money is the most important thing in the world. I'm going to give you an even longer password. Oh, yes. Ooh. Yeah, exactly. I'm going to add a couple more user accounts. Fictitious. These are fictitious, of course. Linda Zhao. I'm going to give you the password of flowers123. Something short. Sam. I'm going to say Sam432. Actually, you know what? Sam, I'm going to have a login of 432432. That's Sam password. Rose Phoenix. You're going to get a password of hello12255. Okay? Yeah, so I'm going to do I have Mystery Flower yet? No, I don't have Mystery Flower. Mystery Flower. And your password is going to be also flower123. There you go. Yep, so we're going to build a database table of users and passwords. There you go. And I'm going to do one more account. Let's do one more. I got Mirza G. And I'm going to give you a password of... Ooh, I got one. Lolcats. 321. Okay. So here we are. We have a database table, or a spreadsheet. To think of it as a spreadsheet of usernames and passwords. Well, login and password. So we have 1, 2, 3, 4, 5, 6, 7 usernames. And of course 7 corresponding passwords. Alright, so here we are. Again, this is a fictitious example. This is fictitious. This is a whole list of logins. If you don't know by now, just everyone that's tuned in right now. I want to give a shout out to all the viewers out there, you know. And now, just imagine, for the sake of argument, that an attacker stole, or, hacked into a database system, for lack of better words, and stole this entire table of all the user accounts on the system. As is. So what's the problem? I mean, there's just one very, very obvious problem. So if an attacker, or a hacker, for lack of better terms, broke into a system, stole this table of users, what goes wrong? As Mystery_Flower said, well, first of all, it has no encryption, and there's absolutely no encryption at all. Everything is in plain text. Okay, so now the the attacker is just laughing to the bank right now. It's like, wow, this was dumber than I thought because all the usernames and passwords are unencrypted, not even hashed at all. It's just out there. Hey, I mean, this is just plain bad. This is everything is stored in plain text. This ain't good. I mean, you see that Linda's password is flower123. You know that Sam Sam's is just a number. Like, really? Wow, Sam Sam got a really weak password. And don't even get me started with what DD Band's password is. Well, some people, you can have a flame one that still. So the problem is that all the passwords, all the passwords, especially all the passwords, are in plain text, not encrypted at all. This is just plain bad. So you may be wondering, like, how often does this happen? Well, define what this means. If you're wondering, like, how often do databases get broken into, the answer is all the time. Databases, unfortunately, get all the time. If you ever hear of something called data breaches, um, on the news all the time, you hear about these things. But you may be also wondering how many systems out there actually still store passwords and accounts and with no encryption, just plain text. And the answer is there are some still, if you can believe it. It's so bad, it's laughable. But yeah, there are unfortunately still some systems out there and people that just don't know any better and just store username and passwords and account information into databases unencrypted, fully plain text. Okay? So, that is this is a quintessential example of how not to store account information in a system. Okay, this is a quintessential example like what you don't want to do. The worst thing that you can do is store everything in plain text unencrypted. So can we do better? The answer is yes. We can do a step better. Okay, let's start with that. We can do something what is called, as Mirza said, hashing. Okay? Okay, golden energy, that topic. Enable two-factor authentication. Ask me again later. Hold that thought about TFA verification. That comes at the end. Please hold your thought, because that's a very important point for later on. We can do one step better. Instead of storing the passwords in plain text, we can actually store the passwords in what is called a hash format. Now, a hash, okay, is generated from what is called a hash function. For those of you who have taken data structures, and have you implemented a hash table before? So a hash table in a traditional data structures course in computer science is for searching, really fast searching, like order of one, like it's to make searching really, really fast. But the heart of a hash table is a hash function. Now there are some very important properties of a hash functions. Ideally, hash functions shall have no collisions. 2, uniform distribution. That means can't be predictable. Cannot be predictable at all. 3, one way. So hash function is no encrypt or decrypt function capability. So the whole idea of encryption and decryption with hash functions doesn't exist. Hash functions are one way. And number 4, they're reproducible. So what this means by reproducible result is, if you take the same hash function on Rose Phoenix computer, Sam Sam's computer, Linda's computer, you feed in like some data, everyone is going to get the same result back. Okay? So how a hash function looks like is this. A hash function takes in some input equals some output, also known as the hash. Okay? The input can be anything, a string, binary, it doesn't matter. Okay? So, I'm going to show you a website that actually has a whole bunch of one-way hash function at md5calc.com. Again, golden energy, hold your thought. So there is a number of one-way hash functions on this page right now. MD5 is extremely well known and old. Okay? Ditto with SHA-1, also with SHA-256. Okay? So the idea is each and every one of these functions work the same. You feed in an input, you get an output back. But the biggest difference between each and every one of these algorithms is the output size, also known as the hash size. Okay? The longer the hash, the more secure it is. Think of it that way. So actually, let's start out with MD5. So I am going to do the MD5 calculate the MD5, a message digest of the string, messy is better than Pinaldo, also is case sensitive. So I'm going to feed in as the input the string to encode, messy is better than Pinaldo, into the MD5 hash function. And the end result is 5C13, yada, 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 all the way down to 11C. Okay? So instead, now we're going to improve on this design of this users table. Instead of storing the plain text of the password, we just store the hash of the password. Okay? We're going to do the same for Golden Energy's password. Money is the most important thing in the world. So we'll do an MD5 of the string, money is the most important thing in the world. And we get this hash back. 405 yada 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 to ends in 50. Yep. You now notice a certain pattern here. You may be starting to notice that the hash size, the hash value size for a particular algorithm, in this case MD5, are all the same. Let's calculate the MD5 of flower 123. Let's calculate the hash of 432 for Sam. Let's calculate the MD5 of hello 12255. Let's calculate the MD5 of flower 123. For C8 all the way to yada yada yada, BF. And let's calculate the MD5 of logcats, all in caps 321. Okay, so now we have improved on the design of the storage of passwords in this users table. So instead of storing the plain text password now, we store the hash of the password. Okay? So here's the good news. The good news is, well, the password, let's say if an attacker breaks in and steals this users table, this table of users, the good news is now that the password is no longer in plain text. But what's the bad news, though? Can anyone tell me what is a very, very bad news still? Anyone? There's two big problems with just storing the hash value. There are two big ones. One of them is very visible here. One of the biggest issues is very visible if you just take a look at the table. Well, okay, so Kyra and Rose Phoenix said two interesting things. Okay, so first of all, Kyra Torov says two of the hash passwords are the same. Two of the hashes are the same. In this case, Mystery Flower and Linda Zhao have the same password hash. They have the same password hash. That means they're both using the same password, or they both use the same exact password as it is. But Rose Phoenix said something else. They could easily decode. Well, remember, when you use hash functions, one of the properties of a hash function is one way. There's no way that you can encrypt or decrypt. So you can't go backwards. So you cannot take this value, let's say this FF4455, all yada 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 606, and work its way back to the original plaintext. There's no function that will allow you to do that. But however, at the same time, let's imagine if, like, I have, the moment you know the hash function, you got it. Okay, yeah. Kyra said, seeing duplicate hash suggests a common password is used and that a rainbow table may be a good idea. Yeah, that is one. But I'm going to prove something to you. So, can they use the hash directly to log in any way? And the answer is, that's a good question. I wanted mini PTH. I wanted someone to ask. So, you can't do that, but how a authentication checker will look like, I'm just going to write in another tab here what the logic is now to check passwords. So if hash in database equals MD5 of user input for password field, then login is true. Something like that. That is like the pseudocode. So the answer is you can't do a hash directly to log in any way, but if you're curious and how on the back end how they would check if, let's say, Linda Zhao's password is, I think this was flower123. I think it was. Is it? Yep, it's flower123. Yeah, okay. So the business logic to check proper password is if the user input of if the MD5 of the user input on the form for the password is this hash, then the login is true. Okay? Alright. But I want to prove another thing. Who do I have not here? Like Kyra. Let's say Kyra. Imagine if your password is football, which is a very common dictionary word. So what is the MD5 of football? It's 37B4 all the way to C0. Okay? So here's the thing, and I want to get to Rose Phoenix's point. They could easily decode. There is truth to that. Although you can't reverse or decrypt because hash functions are one way only, people in the world have already pre-calculated the MD5 value of each and every single dictionary word. So, if you do a simple Google search, we're going to use Google, for the MD5 value of 3B4, 37B4, yada yada, 33C0, what ends up happening is you can actually see, well, the MD5 hash for football is 37, okay, and you see this all the time. These are all the results, okay? So the MD5 is successfully reversed into bit. Someone already pre-calculated the hash value of each and every single dictionary word, which is like 30,000 plus now. Okay? So just storing the straight hash value is not good enough. There is one more thing. MD5, okay? MD5 as a hash function is already broken. Scientists have already proven that there are collisions in MD5. How long does it take to use to find a collision? It takes a long time, depending on how much horsepower or graphics card you use. Okay, so now if you're using MD5, MD5 is broken because there's known collisions. The same is also for SHA-1. Okay, SHA-1 is also broken as well too. Now I'll get to that in a bit, and that also has known collisions. Okay. So, but it doesn't matter whether you use whatever hash function, it doesn't matter what hash function you use. Just storing the hash value is not good enough. Because the biggest thing is, as Kyra said, yeah, you can easily see who here has is using the same exact password. In this case, it's Linda, Zhao, and mystery_flower. You have the same hash, and you're using the same. You both have the same hash for the password. I mean, you're both using the same exact password. Just storing the hash is not good enough. Okay, so now let's go all the way back, and let's start back again. Alright, so just storing this hash value is not good enough. Can we do a little bit better? The answer is we can. What if, instead of just doing a hash of the password, a straight hash of the password, we assign each and every user some sort of a very short token, like a random string. Let's say in this case, 2 characters. Let's say DBAN, I'm going to give you AA. Golden Energy, your token is going to be BC. I'm just making stuff up right now. Linda is AC. Sam is going to be E1. Rose Phoenix is going to be BB. Mystery Flower, you're going to get DE. Again, I'm making these. So the token is just in this case, it's just random. Well, in this case, random 2 characters. And Mirza G, your token is going to be E4. Okay? So what if instead of storing just the and now instead of just storing the straight hash of the password, we hash the token plus the plain text password. So here's what I mean. Let's still stay with MD5 despite the fact it's broken. Even though a hash function has known collisions, people still use it for legacy reasons. So let's do the hash of AA plus Messi is better than Penaldo. Let's still use MD5. AA, and then Messi is better than Penaldo, and that is going to be BC 164. Okay. Let's do BC, prepend that with money is the most important thing in the world. Let's do the MD5 of AC plus the flower 1, 2, 3. E1 plus the number. BB, and hello 12255. Here we do BB, hello. DE is a plus a flower 1, 2, 3. What? E4 lolcats. And there you go. So now let's take a look at what we have now. Okay. All right, this looks a little bit better. So if an attacker steals this database user list of database users, list of users. So we have how many accounts? 1, 2, 3, 4, 5, 6, 7 accounts. Okay, each and every one has a token, and each and every one has a password. Here's the good news now. The good news is, well, we solved the other problem, which is we can't tell who has the same password or not, although we know that Linda and mystery_flower actually use the same password, but we don't know that anymore. We don't know that anymore. So the whole issue of just storing the flat out the hash, all right, that problem goes away. Well, so now if the attacker gets his or her its hands on this, it's like, okay, well, look like I got to brute force and crack all the passwords now. Okay, and that's going to take a very long time. Okay, so this model in where you are assigning a random token to each and every user to be prepended or appended to the plain text password, and then it gets salted and then it gets hashed. This is how modern systems store credentials now. Okay, is they store the password hash, and also instead of token, the formal term is, and someone said, and actually it was Kyra that said this. This is not, the proper term is not token, but it's called salt. Password salt. So what a password salt is just a random character, usually very small, to be used in the hashing of the password to make it look even more random. So someone just can't look at the list of credentials and say, okay, I know that these two people use the same password. Yes, password salting. Okay? Salting passwords 101, accept all cookies. So can someone actually help me understand how salting works? So salting is used to validate a password. Yep, generate a random string hash. Okay. So the whole idea of salt is combined with the password before hashing. Okay, salt is combined with the password before hashing. The password and salt clear values are concatenated and the resulting string is hashed. And of course, this guarantees that even if two people were to have the same password, in our case is Linda Zhao and mystery_flower, you would have different resulting hashes. And it also makes attacks known as dictionary attacks using rainbow tables a little bit much more difficult. Okay, so this is how passwords, credentials are stored on modern systems these days. Okay, so now you know two important terminology. Which are hashing and salting. Okay, you got to know those. Okay, so hashing and salting, you get to know those two in order to understand passwords and also password cracking. So now let's actually understand and take a look at how passwords, credentials are stored on a modern Unix system. Yes, on a modern Unix system. And then what we're going to do is we're going to try to uncover or crack the password on the system. Okay? I'm going to clear my screen here. I'm on my terminal. Can you see? So I'm going to SSH into my RetroPie server. And the password is raspberry. Yep, here we go. Here we go. All right. So I'm going to actually only use three. Okay, so Mirza-G, why is it impossible? It is possible to go backwards, but by definition, one-way hash functions are one way. Okay? So it's not difficult to go backward. Basically, it's impossible to go, to decrypt. There's no such thing. But it is possible to go backward if someone's using a dictionary word or something. Okay? So how do you add a user on a modern Linux system? Is man add user. So I'm going to add a user or group to the system. Okay, fine. That's it. And it has to be done by way of sudo. So I'm going to add a user. Who do I want to add as a user? I'm going to add Golden Energy. I'm going to add Golden Energy to this Linux computer. Add a user Golden Energy. You're going to have a full account on the system. Your password is going to be, okay, your password is going to be Golden Energy. What do you think your password is? I'm going to add Rose Phoenix too. I'm going to create a new account for Rose Energy. Rose Phoenix. I'm going to add Rose Phoenix to the system. Your password is Rose Phoenix. What do you think your password is that I just created for you? Yeah. And I'm going to add another user here. I'm going to do Mystery Flower. I'm going to create a brand new user, Mystery Flower. I'm going to give you a password too. Okay. I'm going to add one more. In honor of Leo Kazuzny's birthday, Leo K. Leo K. Your password is going to be okay. So Leo, happy birthday. I create an account for you on this system as well. Okay. So now, you there, folks? Are you all there? Hello? Are people still listening in? So how many user accounts did I just created on this system? How many user accounts did I just created on this system? Golden Energy 4. Golden Energy, what do you think your password is? DD Band says 4. Yep, I created 4 accounts on the system. Golden Energy, you have any idea what your password is? We'll see. We'll see. We'll see. We'll see. We'll see, Golden Energy. We'll see if it is. Okay. So now we have to know two things. Okay? Well, actually more than two things. First question is, where is all the usernames and passwords stored on a modern Linux system? And the answer is, I'm going to clear my screen, it's in a file called PASSWD in the /etc folder. So you go to cd into /etc, the /etc folder, and there is a file here called PASSWD. Yes, it's a file. If I do more PASSWD, there it is. Here are all the accounts on this system. Yeah, here are all the accounts on this system. You'll see Batman on there. I created that before class. These are all the usernames or the accounts on this system. Yeah, I see Golden Energy, you see Rose Phoenix, you see a Mystery Flower, and you see Leo K. Those are usernames that we just created. Oh, hey, oh, but what's wrong? Well, Batman is, well, yeah, well, who's Batman? Well, we know that. We also want to find that out, too. So first file is /etc/password. Actually, I can't type it in on chat. So I'm going to clear the screen. You can do cat /etc PASSWD. So this is where all the all the account information is stored. What the hell? Yeah. But wait a minute, this should lead up to another question. What's the username? What's the password? Where's the password information stored? What's the password hash for each and every account on this system? That is in a second file. And that second file is also in the /etc folder on the modern Linux system. It's in a file called shadow. Okay? Shadow. So if I do a more, so I'm currently in the etc directory. If I do more shadow, I'm going to permission denied. Well, there's a reason for that. So if I do sudo cat shadow, it's a little different. Now things look interesting. This file now, okay, now you're seeing encrypted information. This is where the password information is stored on any modern Unix system in this file called shadow in the /etc directory. Okay. So here we are, and you can see the user account for Pi, Batman, Golden Energy, Rose Phoenix, Mystery Flower, and Leo K. All have user accounts. Okay. You notice that the user account for the password hash for Pi, Batman, Golden Energy, Rose Phoenix, Mystery Flower, and Leo K all start with the $6 yada 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 all the way to yada yada yada. Okay. So how in the world what does all this mean? How do you read this? Okay. Let's take a look at an understanding of how you read the shadow file. Here's how you understand the shadow file. Okay. There are commonly several different authentication schemes that can be used on a Linux system. The most common ones are the ones here. We just showed the /etc /passwd and /etc/shadow files. The shadow file is a text file that contains the information about the system's user's password. It is owned by the user root and the group shadow. Okay, right. But here's how a shadow file, how you read a shadow file. Each line of the /etc/shadow file contains 9 comma separated values. The first item is the username. The second item after a colon is the encrypted password. That is what we're interested in. So let's take a look at Golden Energy. So Golden Energy, your password hash is all of, let me blow up. Screen. Your password hash is all of this. Golden Energy is the username followed by a colon. The next thing after the first colon is a password hash, all the way up to the final colon. So you see it starts with $6 $6 followed by yada 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 yada, all the way up to another $sign here. And then after the $sign, there's more stuff. So this is how you read the format. How you read it is the following. The encrypted password looks like should be like of the following format. The password is using the $type $salt $hash format. $type is the method of cryptographic cryptographic hash algorithm and can have the following values. $1 it means $1 means MD5. $2A is blowfish. $5 is SHA-256, and $6 is SHA-512. Okay. If the password field contains an asterisk or an exclamation point, the user cannot log in. Okay. So, each and every one of these account information has a $6, which means that the cryptographic hash algorithm, the one-way hash function that's used is SHA-512. There you go. This thing right here, after the $6, that's the password hash. I mean, that's the password salt, sorry. That's the password salt. Password salt, password hash. Same for mystery flower. $6 uses SHA-512. Then this thing that I'm highlighting, after the $6 is the salt. After the $, we have all this. That's the password hash. Yep. Okay. So we have 6 accounts here. We have 1, 2, 3, 4, 5, 6 accounts that we want to crack the password for. So now you understand how modern Linux system stores username and password details, credentials. What happens if you lose your password? What happens if you want to recover your password? And this is where you will need to do something called password cracking. Okay? Password cracking, like anything in cybersecurity, can be used for both good and bad. Okay? The good, of course, is to recover account information. The bad is, well, that goes without saying. So step 1 of recovering passwords is, if you're an administrator, like a system administrator like me, go to my home folder. You want to make a copy of both. You want to get a copy of both the /etc/passwd and the /etc/shadow files. So I'm going to sudo copy /etc passwd. I'm going to copy that to my current working directory. Also going to do a copy of the shadow file as well. You need both. So you need both the passwd and the shadow file. So I'm also going to do a change owner of both the copies of the PASSWD and shadow file to me, so I can actually move them to like another system. So I'm going to exit this Linux system now. So I'm going to go to my desktop, and I'm going to actually get a copy of both. I'm going to download the PASSWD. I'm going to download the PASSWD file, which I just did. You can take a look at my desktop. I'm going to get a copy of the shadow as well. Okay, I just downloaded the PASSWD and the shadow files that were on that Linux system. So here it is. I got a copy of the PASSWD and a copy of the shadow file. And this one should have, yep, Batman, Golden Energy, Rose Phoenix, Mystery Flower, and Leo K. If I take a look at the shadow file, yep, it contains the password hashes for Pi, Batman, Golden Energy, Rose Phoenix, Mystery Flower, and Leo K. Alright, so now I got a copy of both the PASSWD and shadow files from that Linux system. And now let's talk about password cracking. The most famous password cracker around, one of the most famous password crackers around, is called John the Ripper. John the Ripper is a free and open source password cracker. Been around for decades. Again, John the Ripper is free and open source. Okay? Platform independent for the most part. Okay? Here is the website for John the Ripper. If you want to install John the Ripper on the Mac OS, you do using Homebrew, brew install John-Jumbo. Okay? So on Mac OS it's called John Jumbo. What is John Jumbo? John Jumbo is John the Ripper Jumbo supports hundreds of hash and cipher types, including for Unix user password for Unix flavors, Mac OS, Windows, web apps, the list goes on. Okay? So now the modern version of John the Ripper is called John Jumbo. To install John the Ripper on the Mac, ideally you use Homebrew, brew install John-Jumbo. I already have John-Jumbo installed on my Mac, so I'm good to go. How you actually run John the Ripper is quite simple. It's just type in John. At the most rudimentary level, if you type John, here you go, there's a whole bunch of different options. But you may be wondering, okay, so what do you feed in to John the Ripper? You can't just run John and that's it, right? Yeah, that's correct. What you need to do, okay, before you run John the Ripper is that you need to combine or concatenate both the password and shadow files that we just downloaded. So I have a copy of PASSWD and the shadow files on that old Linux system that I have. We need to send both files to a tool that is provided with John the Ripper called Unshadow. Now, I don't think this is going to work on my, Unshadow is not found, so I have to do find -name Unshadow. So I'm going to see where is the Unshadow application is stored on this machine. Now, for the password cracking competition, you don't need to use Unshadow. I already did that work for you. All right, found it. Did or did? Come on. Oh. Let me go to my user folder. Okay. Go to /user. Oh, no, it's not here. /opt. There you go. There you go. It's in the Unshadow tool got installed to Homebrew, Cellar, okay, all this stuff. So I'm going to make a copy of this location. Found the tool. Then I'm going to go to my desktop again. Clear the screen. I have my password and password PASSWD in shadow file. So I'm going to run unshadow on PASSWD and on the shadow file. So the format is unshadow followed by the PASSWD file followed by the shadow file. What? Oh, sorry, it's not a dot. There's a trailing dot here, which I don't need. And the end result is going to be, what do you mean? Oh. Why is it doing that? Let me just CD into, what? Oh. Never mind, I'm an idiot. I have to do an OPT. There you go. My path is all wrong because I was finding the file in the /opt directory. So the tool is called unshadow. Feed in the PASSWD file, followed by the shadow file. Bang, there we go. And so what you see is a concatenation of both the PASSWD and shadow files. Now, unshadow is just going to spit everything out to the terminal screen. But what I want to do is I want to send the result of unshadow, pipe it out to a text file, let's call crackme.txt. There you go. So I'm going to do vim crackme.txt. And I'm only going to care about user accounts that start with $6, $6. Oh, I don't want that. Oops, screwed that up. Try this again. All right, so now we have 1, 2, 3, 4, 5, 6 user accounts here. So more crackme.txt. I have 6 user accounts here. Now we can send this crackme.txt file for password cracking by way of John the Ripper. To do that is John crackme.txt. Okay, are we ready? Golden Energy, are you ready to see what your password was? Rose Phoenix, what do you think your password was? Data with Mystery Flower, what do you think your password was? So we got 6 accounts here. Let's see how many passwords can be cracked by way of John the Ripper. Let's see also how fast it can crack passwords. Not all of them. We may not crack all 6. Highly unlikely. I'll be very surprised if we can crack all 6 just like that. Okay, let's take a look. You ready? Hit the enter key. Now what you do is wait. All you have to do now is wait. And the first thing that John the Ripper will do, it is going to crack password using its built-in word list. So John the Ripper, when you install John the Ripper, it's going to install what is called a word list. Word lists are used to really speed up the password cracking process. Oh, I'm sorry, Rose Phoenix. I am so sorry. So Rose Phoenix account was the first one to get cracked. I'm so sorry, Rose Phoenix. You're the first one to get... Oh, Batman just got cracked. Batman just got cracked. So Rose Phoenix's password was 123456. Batman's password was Robin. I'm sorry. So we got 2 of the 6. 2 of the 6. So it's going to take a while. It can take a while. Sometimes it can be really fast, depending on the the password list that you use. It also depends on your computing power. If you have like graphics cards and stuff, that also helps as well. Okay. So now we have cracked 2 of the 6 accounts. Sorry, Rose Phoenix. Sorry, Batman. You've got cracked. Okay? What's the longest time you've had John running? Oh, what's the longest time? 3 days. That's what, 72 hours? But this was for an odd job. Okay. So this thing is going to keep going. But yes, we got 2 of the 6 passwords. Who are the other accounts that we got? I'm going to open up another tab. Go to my desktop. Okay, so we got Pi. Golden Energy has not been cracked. Golden Energy is still alive. Mystery Flower is still alive. And so is in Leo K. Okay? So now, what we're going to do is, okay, if you're sick and tired of waiting, we got not 1, not 2, not 3, but we got 4 accounts to crack. We got 4 accounts to crack. I think right now, after John the Ripper actually goes through its internal password.lst, its own word list, then it does brute force. What you can do in John the Ripper is you can Control-C out. You can Control-C out of John the Ripper to quit. And then you can run John again later. It will not recrack Rose Phoenix and Batman. If you go to your home directory, CD tilde, and you do an ls minus LA, you see there's a hidden .john folder here. You can see a log of everything that John the Ripper has done so far. All the rules. Oh yeah, here we go. All the rules. You can see all the cracked accounts in the .pot file. There we go. I'm so sorry, Rose Phoenix. And I'm also sorry for Batman. So we got Batman's as well. I forgot what John Rec is. Oh, a record of the last, the Crack Me file, the format of SHA-512 crypt, you know. Okay. So you may be wondering, oh, is there a way that you can speed this up? The only 2 good ways of speeding up password cracking are, number 1, invest a lot of money into graphics cards. So you do password cracking, do a search for password cracking rig. They look like this. Oh yes, some cybersecurity professionals go all out, build custom computers with like a ton of graphics cards in them. I mean, this is thousands and thousands and thousands of dollars. It's also a lot of energy as well, too. And you thought Bitcoin mining was bad. So that's option number one, which is probably what you don't want to do. But the second thing is to use WordList. And I want to introduce you to my friend Daniel Meisler. Daniel Meisler has this project called SecList. It's on free and open source on GitHub. SecList is the security tester's companion. What it contains is a lot of different files and data. It has a word list for password cracking. It has a list of usernames, sensitive data patterns, shells, you name it. SecList is your friend. If you're going to be writing fuzzers to break software, yep, here are fuzzing files. You can see there's also word lists as well. Passwords. In the passwords folder in SecList, here's a list of all possible word lists. There's so many word lists here, some in the gigabytes. So I always have a copy of SecList on my computer. For my documents, go to SecList. CD passwords. So SecList passwords. One of the things, if I do an ls minus lah, Exacto net 10 million passwords is 46 megabytes. Dark code, DARK 0DE is 14 megabytes? Really? Is that right? It's only 14 megabytes? Dark code is only 14 megabytes? Are you kidding me? Dark code, yeah, it's only 15.1 megabytes. Interesting. I thought it was long. I thought it was like in a gigabytes or something. So if you do a word count, how many lines are there in darkcode.txt? 1,471,056 words. So if I do a more darkcode.txt, there you go. It's a list of passwords. A lot of these were found in engagements in other cracked password dumps for years. There's screen. Let's take a look at the Exacto 10 million passwords. 1,000. It's only 1,000 words in this list. There you go. All right, let's do the 10 million one. Word count. So is that no? It's 5 million. It's not 10 million. 5,189,454. All right. Well, in that case, let's use this one. The Exacto 10 million password 100,000 one. So I'm going to go to my desktop now. I'm going to rerun John the Ripper on crackme.txt. But what I'm going to feed in, actually, hold on. Can you all see? I'll blow this up. Here we go. So now I'm just going to run John minus word list equals slash users slash mchow slash documents SecList slash passwords. So the 100,000 word list on crackme.txt. Yep, so I'm going to run John the Ripper, this time using the 100,000 wordless. That is exacto net 10 million. And now we got 4 remaining hashes with 4 different salts. Alright. I'm sorry, Golden Energy. Sorry. You got cracked. Golden Energy, your password was mystery. I'm sorry. Sorry. So now we're down to 3. So we cracked Golden Energy, we cracked Batman, and we cracked, yeah. We also cracked Rose Phoenix. So now you just let this thing run. But now we got 3 of the 6. Okay, we got 3 of the 6. Who will be the last person standing? I don't know. So there's 3 left. There's 3 left. There's only 3 accounts left. So I don't know where. So now you can keep this running for a while. So your best thing now is keep this thing running for a while. Go out and get a cup of coffee. Okay? So, well, Golden Energy, sorry, your password was mystery. So we got 3 left. So we'll let this thing run. Hopefully we'll find 1 or 2 more. We may not find all 6 by the end of today's Twitch stream. But, that leads up to one final conversation. So what you've learned today? You've learned hash functions, password salts, SHA-1. I mean, you've learned SHA-1, MD5. You learned quite a bit. We even learned John the Ripper. We got one down. Raspberry's got me. Well, the pie is gone. Pie is down. Pie is down. Password is raspberry, but I think I said that anyway. So we got 4 accounts cracked of the 6. So now we have, I think, what is it? So who do we got left? I think we got Leo K, and we got, I think Mystery Flower. I think is Mystery Flower? Yeah, Mystery Flower's still alive. And Leo K. That's it. Okay. Your one shouldn't be too hard to crack either. Unfortunately, I'm just gonna wink wink. I'm gonna let you know, Mystery_Flower. Your password is not that bad. Neither is Leo K's account. So we'll let this thing run. But now I want to finish up this conversation. And Golden Energy, are you still there? Golden Energy, you still there? Because earlier on, you mentioned something about TFA. Yeah, you mentioned something about TFA earlier on. And there's going to be a very important lesson to learn from all of this. Here we are now, we're cracking passwords using John the Ripper and Wordless. By the way, John the Ripper is not the only password cracker in town. The password cracker that people swear by these days is, oh shit, we just went through all the entire Wordless. So yeah, Mystery Flower, you are still alive. But maybe we'll go for the 5 million one. What was I gonna say? Hashcat. Hashcat is, this is now the most common password cracker that is used all the time. Now, people swear by it, and for very good reasons. However, Hashcat is a little bit more difficult to use, okay? The reason why I don't teach Hashcat is because if I only teach Hashcat, I really won't have, I don't need to teach how password credentials are stored on Linux system. I don't have to go in depth about the PASSWD file. I don't need to go in depth in the shadow file. I don't need to talk about unshadow. So as a teaching tool, John the Ripper I feel is much, much better. Hashcat has so many options, it's not even funny. But now you're seeing, now you saw John the Ripper used. A little bit of a backstory, anecdote. When LinkedIn got hacked back in 2012, they cracked 60%, hackers cracked 60% of the millions and millions of accounts within 30 minutes using wordless. And you see these guys all the time. These are the latest, worst passwords. Don't use any of them. Yeah, we know. Okay? RockU is there. And here are the worst passwords of hundreds of worst from 2020. Really, this list hasn't changed for the longest time. But now I want to talk about Golden Energy's big point. I want to show you this post from Reddit. Is the time it takes to crack passwords. Here is the time it takes for a hacker to crack your password, and it's still generally true up to this day. If you're using, here's the number of characters, and here is the character set. Numbers only, lowercase only, uppercase and lowercase letters, uppercase and lowercase letters, and all that stuff. Numbers, uppercase letters, and symbols, special characters. If you're only using 4 characters for your password, it's going to get cracked right away. If your password is only 5 characters long, it's going to get cracked right away. The longer your password is, and the more characters you're using for the password, like a mixture of numbers, uppercase letters, lowercase letters, and symbols, the longer your password is, the better it is. I forget when this was written, but you see here at the very worst, a 13-character lowercase letter password is only going to take a year to crack. But the worst case scenario is 18 characters. It's going to take 7 quintillion years to crack. Okay? The bottom line is this. No matter how long your password is, no matter how good your password is, it's going to be cracked. It will be cracked given time. Okay? It's only a matter of when, not if, your password will be cracked. I don't care how good it is. Okay? It could be in 1 second. It could take 1 minute. It could take 1 hour. It could take 1 day, 1 month, 1 year, 1 eternity, 1 century. It doesn't matter. It's all time. Your password is going to be cracked. In fact, that number has only decreased given the increase of computing powers and websites that have been hacked. That stuff also matters as well for password cracking. Your only defense to secure your account, and probably by far the best way to secure your account, is to use something called two-factor authentication. TFA. Okay, what TFA is, you enter your password one time, you enter in your username and password, you hit enter. That's correct? Fine. But then you have to enter in a token, usually a 6-digit number, after you have logged in, okay, to really prove that it is really you that is entering your password. So usually the number is generated on your phone, okay, and then you punch that and then you enter that. So even if an attacker or a hacker cracks your password, and they probably will, they have to get the second key to get through the door. And that's why two-factor authentication is so critical. Okay? Yeah, that is true. Yep. About having a longer password made of random words. Again, it's still going to be cracked some way and somehow. TFA, two-factor authentication, enable it. That's my public service announcement for today. Okay? So no matter how good your password is, it's going to be cracked given a matter of time. enable two-factor authentication for your accounts. In fact, at Tufts, they mandate that for the Tufts account. Also, another public service announcement is this. If you ever been to haveibeenpwned.com, have I been owned? Have I been owned? This is a website where you can enter in your email address to see if it's in a data breach. If it isn't a data breach, then you probably want to change your password for that email address. So this was written by my friend Troy Hunt. I want to give a shout out to Troy. This is a free service. It's also open. A lot of it is open source. This is not, whatever email address that you enter in is not stored. What this is going to do is going to check your email address if it is used in any data breach. And a lot of data breaches have been made public. In fact, you can even buy the data types. So if I type in ming.chow@tufts.edu, let's see if this account has been used. Oh no, this email address has been in 6 data breaches. I don't know what the fuck Apollo is. I don't know what this 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 is. Gonna mchow@cs.tufts.edu and enter, and then add. Oh no. Oh, that sucks. Yep, that was in a LinkedIn breach. That sucks. Terrible. I'll see my Gmail. Oh no, 2 data breaches. I hate this so much. Okay. Now you can just enter in your email address and see if it wasn't a data breach. Yeah. Hey Tonics, how are you? Yes. How are you, my friend? Thanks for tuning in today. Well, folks, that's all I have for today. And now I can actually say that the password cracking competition for the fall is now officially on. Okay? So that's all I got. It's a long, dense day today. Alright, hope you enjoyed. Hey, Tonics, yeah, thanks for tuning in, man. Everything alright? Yeah, hope all is well, and yeah, just to let you all know, Tonics, I still owe this guy a beer or 3, yeah, because he gave me a the Portland Timber scarf, yeah, MLS is the thing these days. Alright, folks, yeah, enjoy, I'm going to turn off now. There you go.